We all know this feeling: wilting plants, cracked earth, and the worry that comes with a drought. But what if a hidden network could make your plants absorb water and nutrients 4 to 7 times more effectively? This isn't just about bigger roots. It's a 1,000-fold increase in the plant's resource-gathering web. The source isn't a fertilizer or chemical. It's a living partnership with mycorrhizal fungi. Now we will break down how this network expands reach, reprograms plant biology, and engineers the soil itself. It begins with a simple ancient trade. The plant provides the fungus with energy from sugars. In return, these fungal threads, or hyphae, become a hyper-efficient root extension, at least 100 times better at absorption. These microscopic threads penetrate tiny soil pores and cracks that are completely off-limits to plant roots. The fungus also signals the plant to grow more of its own lateral roots, creating a feedback loop of absorption. This network is a superhighway for phosphorus and nitrogen, delivering them even when soil is dry and nutrients are locked up. So the fungus expands the plant's reach, but it also changes the soil to hold more water in the first place. The fungi produce a unique substance called glomalin. Think of it as a biological superglue for soil particles. This sticky protein binds tiny particles into larger aggregates, creating healthy topsoil. How does that beat a drought? These aggregates form a network of pores that allows rainwater to soak deep into the ground, turning soil into a giant sponge. The fungus alters the physical world outside the plant. Now let's go inside the plant to see how it rewires its biology. The fungus influences when the tiny pores on a plant's leaves open and close, leading to precise water conservation. On a genetic level, it affects aquaporins, proteins that act as water channels, upgrading the plant's internal plumbing. Remember that soil superglue? In studies on maize, this partnership led to 30–50% higher water use efficiency. This advantage is most pronounced for young seedlings. For them, this fungal link is the difference between life and death. And at maximum potential, this symbiosis can unlock 4 to 7 times greater utilization of soil nutrients and water reserves under the right conditions. So we have physical expansion, soil transformation, and biological optimization. The result is profound resilience. But this isn't a one-size-fits-all solution. There are thousands of fungal species, some adapted for extreme conditions. Take Senococcum geophyllum. With its melanized root tips, it is a drought specialist that thrives where others would fail. The fungus also acts as a hormonal regulator. It can trigger more abscisic acid, a key hormone for drought defense. Drought causes oxidative stress and cellular damage. Mycorrhizal plants have superior antioxidant systems to neutralize this threat. With all these integrated mechanisms, it feels like a co-organism. How old is this relationship and what does it mean for Earth? The answer is staggering. This partnership is nearly 400 million years old. Without it, plants may never have colonized land. Connect that immense timescale with the soil superglue, glomalin. This network has been building the world's fertile topsoil for eons. And recall the nutrient superhighway. This ancient system does the work of industrial fertilizers without the environmental cost. When we work with Mycorrhiza, we are using a 400 million-year-old operating system for planetary resilience. Mycorrhiza is a foundational partner that expands a plant's body, rewires its biology, and engineers its environment. So the way to make roots far more efficient, delivering 4 to 7 times greater water and nutrient utilization and outlast drought, is no modern invention. For gardeners and farmers, this means protecting soil life is paramount. Reduce tilling, use cover crops, and limit chemical use. In a world with increasing water scarcity, working with this hidden kingdom is a strategy for food security. Look deeper than the leaves. The future of resilience is in the soil, waiting for us to partner with it.